Good afternoon, everyone. This is Alex Seguin, CEO, co-founder of De-Risking Strategies. We're going to do our first webinar and really just discuss where we're headed, what we're doing, and I'm going to give a brief intro of the company, introduce a co-founder, Bart, and go from there. So to begin with, who are we? We're basically an experienced sensor and AI ML development team, so machine learning for those who aren't aware of the acronym. Our goal really is to help with global development, establish multi-partner collaborations. As many of you know, the AI space is growing pretty fast, and there are areas where multi-partner collaborations or multi-company collaborations will benefit end users. So I don't believe that there's a future where one person can do it all, right? But the next thing here is our expertise with Bart and I is really sensor fusion. So visual camera is one area, thermal is another, LiDAR and some other sensor options we're trying to get into with potentially robotics applications in the future. All right, so I'm going to introduce myself. So our leadership team is really Bart and I, both co-founders. So my background's in strategic marketing, Honeywell, portfolio management. I have launched a lot of products at Fluke prior to FLIR. And last role, I was actually in a research and development portfolio manager role. I'm managing about a $200 million portfolio at FLIR. I do have a background at US Air Force where I was actually a sheet metal mechanic. So I fixed a C-5 Galaxy aircraft out in San Antonio, Texas. And I'm currently enrolled in the Harvard Business Analytics program at Harvard, where the focus is really data analytics, machine learning, where the world's going for executive leadership. Bart, how about you introduce yourself?
Yes, hi, you guys. Thanks everyone for joining us this evening. That's great to have you here. My name is Bart Neumann-Beck. I'm the CTO and co-founder of De-Risking Strategies. Over the last 25 plus years, I've been working on either working on or delivering multitudes of products, based hardware, software. They've done ASIC design, chipsets, developed servers, scopes for, oscilloscopes at Tektronix, spacecraft electronics earlier in my career, advanced CMOS processes. And as Alex noted, imaging products like thermal or acoustic imagers. We've done many of those. I was the CTO for the oscilloscope division at Tektronix for many years. And so technology interests me a lot. And one of the things that I note is AI and ML is the next thing. And it's pretty exciting to be part of this team, to see what we can do here and take this technology to the world, I guess. We have assembled a very diverse team. It's very interesting. Alex notes that we're a very experienced ML AI team. That wasn't the case in the beginning. We have Pushkar, who has the formal training. But when we developed the kit and capabilities, and through that process, the rest of the team became very familiar with AI and ML. And I think I can say that most of the team here are very proficient modelers now. And for me, if you go take through the, we've all gone through the modeling process. For me, the most exciting thing is, and I don't know how many people online have done this, but taking an image, annotating that, you can't beat that. It's the funnest thing.
I think that Sabrina will say that seeing the results actually transpire into some greater model to actually do something like identify a person is actually very satisfying as well. Thanks, Bart. And I'll just put a special note out there to advisor Ken Colden. He's in the HBAP program with me at Harvard, and then our partners, Cloud Media Work as well. For those who are aware of artificial intelligence, machine learning models, the basic example that's always taught in academia is this 28 by 28 grid of kind of the hello world of machine learning. And it teaches the basics of neural networks. Where you have number identification. They teach the theory of the layers, everything else. So that's on the left side here. Feel free to go to that on your own at 3 Blue Brown series. You can see it at the bottom left. What's really exciting though is that right picture, which is actually showcased in one of the posts by Steve Norrie on LinkedIn. And the example really is of live pictures without any kind of Wi-Fi. So edge computing, where you can identify the model of the car, the color, even the license plate. So there's real-time number recognition going on. As you can imagine, this is probably used in some applications such as like border crossing, as well as maybe even just, what is it, the toll tags and toll roads here in Texas, as well as California and many others such as Seattle. Okay, so this is an important slide from my standpoint, but what's changed 5 years ago, right? Or since 5 years ago? There have been significant advances in the AI ML hardware, but basically there's off-the-shelf software and hardware and many advances, even Python, TensorFlow Lite from Google, that significantly makes it easier for the average person to do their model. So we're at a point now where we feel that there's not any technical expertise required to do something cool like identify an image or a video to detect, for instance, Alex Seguin in my case. So those models are possible off the shelf. There's very cool things like Google Coral Accelerator, which helps advance machine learning models in deploying out in the world. Remote work is now a thing, as many of you know, but we feel like there's a possibility with virtual teams to help drive AI machine learning and actually do it more efficiently in the past than actual in-work collaborative environments. You know, there's a lot more reaching out. Actually, our whole team is virtual, and we've managed to somehow get these cool products all the way from Portland to Michigan, Texas, but just having the ability to and desire to want to have this global kind of collaboration network is finally possible. And then I'll say probably the most important thing is these hardware is getting cheaper and cheaper and cheaper. The example I just looked up LiDAR systems. LiDAR systems for laser detection and distancing used to be something like $3,000 to $4,000. There's the highest performing sensor by Intel now. I looked it up earlier. It's a higher than a 1080p in LiDAR, which is pretty high performing at something like $350, right? So LiDAR is now also, for those who are aware, even on now the iPhone 12 Pro and above, but there's a little sensor on these phones now that enables you to do cool things that will enable augmented reality, distancing using your phone, but have a higher sense of precision when you're even doing measurement for even the Apple products. All right, Bart.
So why are we, why are we launching? So when we first started, Alex and I were looking at this problem, and traditional college education, it takes 6 years to before you get exposed to AL and ML in their curriculum. So basically, master's degree level, and that comes at a significant cost. It's not inexpensive to go to school, and so by the time you've been there for that long, you're spending close to $90,000 or more to just get access to this new technology. And we know that at secondary education, high school level, or middle school, high school level, there's like very little exposure. And we said, well, there's no reason why we can't enable our students at the middle school and secondary education levels with to get involved in AI and ML. So we provide a hands-on AL, ML experience through this learning and this kit. So over to the right-hand side of the foil, you can see some examples of what our kit can do. Whether it's object recognition or personal recognition. We have a sensor fusion where we have the lower left or lower right, excuse me. There's a thermal camera involved in a security application, but we can mount that as well with sensor fusion, where we do both visible and thermal at the same time, so we can increase the accuracy of our detection. But that's really why we're doing it. We want to get this capability down into the high school levels.
Yeah, so the setup sort of process is pretty easy. In this case, you see that white cord. It's a Google Coral accelerator, which helps with TensorFlow light models, which is faster inferencing. And Pushkar has actually gotten the code down for the novice user to 2 lines or less. So 1 or 2 lines of code to run a model out of the box, right? So setup process is 2 to 5 minutes. And here's an example of a thermal. And these models we actually develop ourselves for human detection. In a bit, you'll see actual annotation process, which is the ability to go and label images, in this case, dogs, and pretty simple process for a non-technical expert. So very important to remember here is it's pretty easy out of the box, but more importantly, we're here to help you and guide you through the process. Our goal is to eventually get into 500 schools in 2021, whether it's through the students and the parents or directly in the school district. But we're looking for pilot programs. We're actually really excited to work with a Dripping Springs High School where they have a pretty good robotics team already in place and very advanced applications there. I'll also mention where I went to school, Pflugerville High School. We're taking part of shaping the P-Tech curriculum, where we're helping the high school CS, computer science program, accelerate their entry into AI and machine learning.
I want to note that, you know, Dara is obviously hyper accelerated in that video, but the experience when you take it out of the box, put it together, get the command line structure, and then actually execute the canned programs takes 5 to 10 minutes. And we actually have taken these kits to people who are unskilled, not necessarily computer specialists at all, and they are also up and running within 5 to 10 minutes.
All right, so I'm gonna hand it over and stop sharing my screen, and then Pushkar is actually gonna run you through a live demo. We encourage any questions in the Q&A bar, and we'll unmute people or allow that feature after or during Pushkar's demo.
So the first demo I want to show is a Google, a pre-trained model which can detect like 90 common objects.
And so Pushkar has a webcam at his desk. This is live streaming, and you'll see a person recognition. I think it has a chair on the left side, as well as even at the keyboard sometimes will come up. But this is out of the box, ready to go. And we'll explain kind of how the process works later on. But Google spent some time on annotating a whole bunch of images that they provide available for the public. Many of you will know the iNat or iNatural programs for insect detection, plant detection, as well as bird detection, but there's something like 1,000 to 2,000 of each of those categories labeled. Probably heard of those, and for those who are aware of AI machine learning. Also important here is this is inferencing or making a guess at what's on the screen at 20 frames a second. So that's pretty uncommon, but basically this device here in white, it enables you to, it's a Coral accelerator by Google, and it turns your Raspberry Pi into a PC-enabled device that does about 5 frames a second, and you get 20, so 4 times the speed. All right, Pushkar.
Yeah. So the next demo is for the check ID model, which actually detects who the person is. So for this model, we have actually trained 4 of our team members, me, Dara, Alex, and Nick. And the model which I'm going to show you can detect 4 persons. Okay.
There you go. So again, this is a live version, but you can see that it's identifying Pushkar, his name, because we labeled him through about 700 to 1,000 frames. I manually labeled the process, and it's, what's the frame rate, Pushkar?
It's 24 to 25 frames per second.
Yeah, so in this case, it's a little faster, 25, just because there's 4 objects that are being recognized in that model. So really important here is that we develop this model will help teach you and guide you through the process. So whether you want to do Santa Claus, a Christmas tree, your cats at home, your parents, or even just for those who want the hands-on experience or post-college, we're here to help you out.
So the next is the pose estimation model, which actually detects the coordinates of different parts of the body, like elbow, shoulder, position of eyes, and all those things.
And Pushar is going to stand up for this one.
Sure.
Yeah, so the capability is from Google. It's a pre-embedded model or pre-compiled model, they call it. But basically, it determines all joint locations through the imaging, determines your left shoulder versus right shoulder. A lot of people have actually taken this and done physical therapy applications where you can detect angle or range of motion. But this is basically turning your camera into something a little more powerful. Again, this is the out of the box solution from Google. But you can imagine in more advanced cases, maybe if you have two cameras, you can get to a 3D interface of what that left shoulder, right shoulder, and where they are in position each other for range of motion. But just the ability to identify through images, your skeletal figure, basically, pretty powerful. And we'll save the best for last, but we have thermal imaging coming up next. Yeah. And just so you're aware, there's a thermal imaging module. You can buy these online as well, but it turns your, basically it lets you see objects at night without any light. Every one emits a little bit of infrared, but it lets you see objects pitch black conditions, and you'll see the heat emitted off the pushcar. What's more important is we actually trained a model for a person on this as well. And you'll see he steps away. For one, the heat on the chair is actually recognizable, but you can detect a person in pitch black conditions now. So this doesn't matter if you have a visual camera or not. Again, you can imagine you're on your perimeter of your house, you can see an individual. All right, Bart.
Right now we're running a Kickstarter, but if you want to learn more about our products and what we do, these are two places to go. What's nice about the Kickstarter page is that it actually shows the breadth of the products that we're offering, anywhere from, you know, very basic kit for a beginner, all the way up to a very complicated multi-sensor kit that you know, you would be for an advanced person who actually had been doing this for a while. As we note, our job is to help you be successful. So as you go through this, we load the kits up with some preloaded models so that the user can, or our students can see what is possible, and they will get excited, hopefully, that, hey, well, that looks pretty cool. Then we will enable them to make their own models, and then they can do whatever. I mean, it's, you know, the sky's the limit, actually. The page does contain a lot more information, again, like I said, of the company and what we're up to. Does have contact information. So if you have questions that you don't get to tonight, we certainly can get to you later. And if you were ever to pick up one of the kits and you had questions about it, that's a great way to contact us if you have any issues or concerns, or actually thoughts or feedback.
All right. Thank you, Bart. I'll just plug the email address for those who want to email us, deriskingstrategies@gmail.com, or even just email my personal address at a.seguin@deriskingstrategies.com. So I'm going to go into Q&A, but I do want to end with the AI ML technology solutions and a mention of the eXeL AI initiative. So Sabrina Queen, actually, she and I went to middle school. We knew each other in high school. She's now our educational outreach manager, and we drafted this strategy more to accelerate and provide an educational initiative for and design for the secondary education system, so high school, trying to get in below that as well eventually. But the idea here is, you know, help support us. We're trying to provide more and more kits. We're just at early fundraising. Then we're here to help you learn. So for those who've never deployed their own machine learning model, we're going to do it with you. We'll actually do the machine learning first. And our hope is to build some of you guys up to the ability where you can do it yourselves. And we actually got that code down to about basically a drag and drop process of 3 lines of code in Lambda Labs Cloud. But yeah, so it's pretty easy. We'll do it for you the first time. And our hope is you'll want to continue to do your own models. We have robotics planned next. So this was all around trying to get a first product out there, but we're going to go into kind of student versions of robotics and machine learning applications where maybe your toy robot or even a more advanced robot will not only follow you around, but do things for identification of the environment around it, right? And eventually, just so you're aware, we do have some interns working with us, but we do want to establish internships, externships, as well as full-time opportunities as we grow. So I'll end with that and go into Q&A.
We have a couple comments, questions came in during the talks. So let me address those first.
Yeah.
There was a question about do police cars use these technologies? And can't be 100% certain. I don't think they do so yet. They certainly could be deployed. But if you were to look at a standard, squad car right now, they wouldn't have this, but they could in the future.
Yeah, let me build up on that from an earlier conversation today, but talking about TSA, for instance. There are goals, for instance, to do kind of a screening of individuals, automate certain processes. You can imagine with like an identification check or like a check to certain IDs, you can tell individuals. Actually, Sabrina and I are talking about a use case where you could potentially say who on your school is not part of the student population or the teacher population. But to our knowledge, none of these AI machine learning capabilities have been broadly deployed. Military applications, I'd say they're probably a little closer, but still such a growing field and it's pretty fast and evolving. So our goal really is to establish these sensor fusion opportunities where you use 2 or more sensors and have machine learning models for each one of the sensors so you can do a task that was previously impossible with a single device by itself.
Tony Shockley asks, what is the IR camera resolution?
Tony, nice to see you. Hope all is well in Seattle. We have a 320 by 240 sensor here. And this is actually pretty powerful because it uses the onboard processing capability of your PC, and it actually looks a lot higher, just so you're aware.
Tony also asks, what kind of great opportunities for initial user base? In other words, what kind of things can they do?
Yep.
You want to give them some suggestions?
Yeah. So we're looking at, for instance, the initial training is going to be around checking your own identifications. So just the ability for you to detect you versus your sister versus your brother or parents. And that'll be the first model we want everyone to get the hands-on training with. From there, there's a lot of applications, kind of up to your imagination. Our robotics friends in Dripping Springs mentioned they want to use a little bit of AI machine learning for staying in the lines of a track and having their robot go and automate its way through a course, right? So similar to what kind of Tesla does, at a very low level, we feel like it's possible with machine learning. Things like stop sign detection, other detection, whatever models you want to detect for objects, you can do. And then on the pose estimation or even the thermal, you can do from pose estimation to just anything where you need your angles of certain body motion. And on the thermal, a lot of nighttime detection kind of capabilities. So our goal really is to enable those with existing thermal imagers one day to add capability to their devices as the APIs and SDKs are made available to the public.
Anthony asks, has this technology been used in warfare? And I'll take that one. the sensors that we utilize, some of them do have dual use and have been used in weapon systems for sure. Has the combination of ML and AI with sensors been used, or has it been contemplated? Same thing. It's going to be a dual use. So there's the use cases can be education, security, as in some of the other use cases that Alex mentioned, but certainly the government's interested as well.
Yeah. I just mentioned the complexity of running a project, even in a government case or even for industry, is if you're a thermal expert, it's very hard for you to pair up with like a LiDAR expert. And traditional boundaries between companies aren't as easy to navigate. So those who are willing to collaborate with other companies, for instance, Bart and I have an acoustic imaging background. It's pretty hard to get all the players in the room to say, here's how we're going to go and add value to end customers. And we're going to share, we just feel like it's the best thing for the end customer experience. So it's possible. It's traditionally hard. And I'd say if you want to get into it, really push your leadership teams in your companies. So current curriculum, we're actually looking for pilot schools right now. Those who wish to purchase our kits earlier than Q1, Q2, feel free to reach out to us. We have the Kickstarter, we'll probably launch an e-commerce store. The current curriculum, I'd say I wouldn't even target necessarily computer science. That seems the natural fit. But in our case, you don't need programming expertise to develop your first machine learning model. And it's that simple now, where we have all the code in a very user-friendly format. I will also plug that there is a UI, UX being developed for 2 or more sensors. We're calling it Sensor Fusion app for now until we have a more appropriate name, but it will even be easier. We're targeting middle school simplicity. So for anyone who wants to do object detection on whatever they want in the world, or apply that object recognition to the robotics system, that will maybe even develop a toy where it doesn't hit your walls and can follow you around your own house. We're interested in getting where we can. Natural fit, again, it seems like it's computer science robotics, but you don't have to be a computer science or robotics student to get introduced to this technology and actually come up with good models and good use cases.
Alex, I think we have been accepted into some of the high school systems for part of their STEM programs, correct? Correct.
So we're currently in the Pflugerville ISD, helping them with their PTech program. PTech is actually a program that introduces computer science and tries to get students to an associate's in computer science level. And we're going to help them with some of the machine learning curriculum over time. And then there's Grapevine. We have introduced it there as well, up in Grapevine ISD, as well as the Dripping Springs, like I mentioned, which is a pretty good robotics program already. But our goal is really to pilot in those 3 areas and bring up as many schools as we can through the hands-on learning curriculum, and eventually have a formal curriculum as well.
So we have a question. So can we add ML models, and how much is the kit, and is the kit available to everyone? So I can answer those. So we do preload the kits with some off-the-shelf models, so that, again, like I said earlier, you get a chance to understand how this thing works and what you can possibly do, and then use your imagination to go from there. So yes, you can add your own models. We will help you create your own models, as Alex has noted. The kits go, if you go online to the Kickstarter, you'll see the kit costs. They go anywhere from $200 to up $800 for a visible only sensor package, but they can be much more, about $1,000 or more for a thermal kit. Is the kit available for everyone? You have to be, well, we're targeting 16 and older for right now. So anyone younger would have to have adult supervision, but they can certainly use it. Anything to add there, Alex?
I mean, I guess on the machine learning model aspect, I'll give the example that we started with, which was initially a friend Amanda's dog, and trying to model a dog for the first time with thermal, right? The cool thing here is if we have enough people in the network, your model might work 50% of the time in thermal, for instance. But as we maybe put out challenges for people, have maybe competitions is my goal eventually. We can source other people who are having the kits to maybe annotate with us and have a more solid performing machine learning model. So it's really the power of numbers in this case, which will get to higher end models that help you really evolve to your future needs with the application you're going after.
Ron, that's a good idea about conducting paid AI ML courses for 101 level. Probably sounds like introductory college classes. Yeah, it's a good idea. We certainly would also want to reach out to the introductory college levels and get those kits into those classes as well. Sure, good point.
Yeah, building upon Bart's comments as well. The idea here is we're going to pilot with whatever skills we can. If you have friends or family or someone who wants to even donate 5 kits to a local high school to get them accelerated on their journey, definitely reach out to us. Sabrina and I will work out some arrangement where that can be done. We're just, again, trying to get these pre-established models, getting them out to the kids, getting the hands-on training, and accelerate the entrance into AI. And again, no technical backgrounds needed, right?
Alex, you want to explain the, I'll call it the skill level program?
Basically, we have a leveled program where within our network, we're establishing like a level 1 through 4 program where you can go from annotation level 1 to 4. And as you get the experience, you go from like A1 to A4. In the case of Python, we do want to expose, for those who are interested, the basics of Python. So we'll walk you through some basics, but just to get started on the kit, you can stay in that swim lane for annotations. You can also, if you're interested in actually doing your own AI ML models, our prerequisite almost like a Python exposure, and how that looks on the right side just for the AI ML, because Pushkar knows this process very well. They teach it in master's programs and above. But basically, we're going to teach you how to go from setting up the models, cleansing the images, and then going all the way through eventually supervised training where we help you out. And then after that, what a level 4 is basically you can do your own machine learning models by yourself, whether it's Google, Colabs, Lambda Labs Cloud, which we use a lot, on your own GPU, like the Tensor book from Lambda Labs, or even AWS or Azure. Will help you through that process and learning by yourself if you want to go that far. So applications for good opportunities for the initial user base. Again, detecting basic objects. I'll say that the one I kind of always go to is like once you have a robotic solution, if you want to just embed AI ML to your existing robotics or your robot experience, stuff like identifying a ball or a person and following you around that house, right? We think there's going to be a day where you can use these to supplement your learning and have like a R2D2 type of equivalent around your house, even if it's just following you around for now. But the more applications, as we build this together, I think it's going to be more and more possible. One key thing I didn't really mention is all these machine learning models run on your device without any Wi-Fi. So once you download the updated inference file, that's what we'll provide to you from your imaging that you annotate. It's basically standalone. So you can be out in the middle of nowhere without Wi-Fi and at least run the model to detect whatever you're trying to look for. Bart, any other questions out there?
I don't see any other questions at the moment.
So I want to say personally, thank you for joining this webinar. Again, this is our first one, but we're just trying to help out and getting exposure to students and learners of all ages, just to give you the first hands-on training in the AI space. So, in a day where you traditionally have to go to a master's or a degree program, PhD in some cases, start early, see if you even like it, and then figure out which direction you want to drive your career. AI is probably one of the fastest growing spaces today. Some people refer to it as like the 4th technology revolution and just very fast paced. But, even the National Science Foundation has a curriculum and a program in place to help stimulate retraining for adults to try to get AI and machine learning into the everyday user who's maybe wanting to retrain into a new field, right? So we actually trying to get government grants. So any of the success we build now will be applied to future opportunities, and hopefully we'll get into more schools as we grow. So we appreciate the support. Again, we're here to help you, and hopefully hire some of you in the future. Thanks, everyone.